The latest on Mars. Mysterious structures have been discovered hidden under the surface of the planet Mars. And here we have the image of dense gravitational structures. This is the northern hemisphere of the planet. A team of scientists presented a new gravity map of Mars at the Europlanet Science Congress 2024. The map shows the presence of dense, large-scale structures under Mars' long-gone ocean, and that mantle presence are affecting Olympus Mons, the largest volcano in the solar system. The new map and analysis indicate data from multiple missions, including NASA's InSight, that's the interior exploration using seismic investigations, geodesy, and heat transport mission. They also use data from tiny deviations in satellites as they orbit Mars. The paper, The Global Gravity Field of Mars Reveals an Active Interior, will be published in an upcoming edition of JGR Planets. The lead author is Bart Root of the Delft University of Technology. Some of the results go against an important concept of geology. Geologists work with a concept called flexural isostasy. It's described how a planet's outer rigid layer responds to large-scale loading and unloading. The layer is called the lithosphere and consists of the crust and the upper part of the mantle. When something heavy loads the lithosphere, it responds by sinking. On Earth, Greenland is a good example of this, where the massive ice sheet puts downward pressure on it, and as its ice sheet melts due to global warming, Greenland will, of course, the landmass of Greenland will rise. This downward bending often causes an uplift in surrounding areas. Though the effect is light, the more massive the load is, the more pronounced the downward bending, although it also depends on the lithosphere's strength and elasticity. Flexural isostasy is a critical idea for understanding glacial rebound, mountain formation, and sedimentary basin formation. The authors of the new paper say scientists need to rethink how flexural isostasy works on Mars. This is because of Olympus Mons, the greatest volcano in our solar system, and the entire volcanic region called the Tharsis Rise or Tharsis Montes. Tharsis Montes is a vast volcanic region that holds three other enormous shield volcanoes, Arsia Mons, Pavonis Mons, and Ascraeus Mons. Flexural isostasy states that this massive region should force the planet's surface downward, but the reverse is true. Tharsis Mons is much more elevated than the rest of Mars' surface. NASA's InSight lander also told scientists a lot about Mars' gravity, and together it's forcing researchers to reconsider how this all works on Mars. This means we need to rethink how we understand the support for the big volcano and its surroundings, the authors write. The gravity signal of its surface fits well with a model that considers the planet as a thin shell. The research shows that active processes in the Martian mantle are boosting Tharsis Mons upwards. There seems to be a big mass, something light, deep in Mars' layer, possibly rising from the mantle, the authors write. It shows that Mars might still have active movements happening inside it, making new volcanic things on the surface. The researchers found an underground mass around 1,750 kilometers across and at a depth of about 1,100 kilometers. They suspect that it's a mantle plume rising under Tharsis Mons and strong enough to counteract the downward pressure from all the mass. This suggests that a plume head is currently flowing upwards towards the lithosphere to generate active volcanism in the geological future. The authors write in their paper, there's debate about how volcanically active Mars is. Although there are no active volcanoes featured on the planet, research shows that the Tharsis region has resurfaced in the near geological past within the last few tens of millions of years. If there is a mantle plume under Tharsis Mons, could it eventually reach the surface? That's purely speculative, and more research is needed to confirm these findings. The researchers also found other gravitational anomalies. they found mysterious dense structures under Mars' northern polar plains. They are buried under a thick, smooth sediment layer that was likely deposited on an ancient seabed. The anomalies are approximately 300 to 400 kilograms per cubic meter, denser than their surroundings. Earth's moon has gravitational anomalies that are associated with giant impact basins. Scientists think that the impactors that created the basins were denser than the moon, and their mass has become part of the moon now. Impact basins on Mars also show gravity anomalies. However, the anomalies in Mars' northern hemisphere show no traces of them on the surface. These dense structures could be volcanic in origin or could be compacted material due to ancient impacts. There are around 20 features of various sizes that we have identified dotted around the area surrounding the North Polar Cap, one of which resembles the shape of a dog, said Mr. Root. There seems to be no trace of them at the surface. However, through gravity data, we have a tantalizing glimpse into the older history of the northern hemisphere of Mars. The only way to understand these mysterious structures and Mars gravity in general is with more data. Root and his colleagues are proponents of the mission that could gather the needed data. It's called the Martian Quantum Gravity Mission, MQUALS for short. MQUALS could be based on the same technology used in the GRAIL, Gravity Recovery and Interior Laboratory, and GRACE, Gravity Recovery and Climate Experiment missions, which map the moon's and Earth's gravity respectively. MQUALS would feature two satellites trailing each other and connected by an optical link. Observations with MQUALS would enable us to better explore the subsurface of Mars. This would help us find out more about these mysterious hidden features and study ongoing mantle convection, as well as understand dynamic surface processes like atmospheric seasonal changes and the detection of groundwater reservoirs, said Dr. Lisa Warner of DLR, who presented on the MQUALS mission at EPSC 224 this week. This was originally from Universe Today by Evan Coe, and it's on Science Alert. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.